Hello, algebra students, and welcome back to another summary video. This video is going to summarize what we learned in part 2 of our lesson on writing equations to model relationships. Obviously, the goal of this is, can we write equations? But a little more specifically, part 2 was really focusing on tables. So there was 2 goals. We wanted to be able to identify patterns in tables of values, with the goal of being able to identify those being that those patterns are going to help us generalize those relationships and write equations to represent those relationships. Now, when it comes to representing relationships, sometimes the relationship between those two quantities is really easy to see, and it's always true. So, for example, we know that the perimeter of a square is always 4 times the side length. Right? Anytime you're trying to find the perimeter of a square, it doesn't matter how big or small it is. There's 4 equal sides, so we know the perimeter is always going to be 4 times that side length. That's where formulas come from. Other times, though, the relationship between those quantities might take a little work to figure out. It's not going to be as obvious. And the key to figuring out what that relationship is, what that mathematical relationship is by looking for a pattern. And tables can be huge in helping us discover what that pattern is. So in this summary video, we're going to look at 2 examples to help us summarize what we learned in this lesson. For the first example, we're going to be talking about a plane's path. So the situation we're given here is a plane departed from New Orleans and is heading to San Diego. The table shows its distance from New Orleans, which we're representing with X, and its distance from San Diego, which we're representing with Y, at some points along the way. So we have a plane taking off in New Orleans and landing in San Diego. And my table is showing me how far it is away from those 2 cities at any point in the flight. So we've got a couple values already given to us in this table. And then row 4 is that first row where we've got a missing number. We've got another missing number in row 6 as well. The first question when I'm looking at this table is I want to see, do I see any patterns in how each of these quantities is changing? We're going to be on the look for patterns in this table. And if we find that pattern, we can use that pattern to help us find out those missing values. I encourage you, go ahead, pause this video now and see if you can find some patterns in this table. Now, I'm going to start off with the first pattern I hear a lot from students, and I think it's probably one of the more obvious ones when you first start looking at this table, is students a lot of times first notice that the numbers here are increasing by 200. So 100 plus 200 is 300, 300 plus 200 is 500, and the numbers over on this side are decreasing by 200. And that's a great observation, but the problem with that pattern is this number down here. If I'm trying to use that to help me fill in these missing numbers, it's not going to help me when those numbers don't go up or go down by 200. So when we're talking about patterns here, we really want to see if we can figure out a mathematical relationship from this number to this number. We're trying to figure out what math is done to X to get Y, or what math is done between X and Y, figuring out that relationship between these 2 numbers here. So if the only thing you noticed earlier was that 200, pause the video again and see if you can figure out how the X and the Y numbers are related. So how 100 and 1500 are related, how 300 and 1300 are related. And if you're still not quite sure, another hint I'm going to give is just start going through the different operations. This relationship we're talking about, when we're talking about a pattern, patterns use an operation. So addition, subtraction, multiplication, or division. So we could play around with addition and see if we notice anything. If we don't notice any pattern, play around with subtraction and see if we notice anything, and just go through those operations. Remember, we said earlier that it's not always going to be obvious and it might take some work to figure out. So as you're playing with those operations and seeing if you notice any pattern, using addition, I start to notice a pattern here. I notice that if I add that x number, that x value, and that y value, every single time I'm getting the same thing. I'm going to get that 1600. So that's true for that first row. It's true for my second row. And when you notice the pattern, you want to make sure it's true for everything. I'm checking. It's still true for that third row. I don't know this number here, but there's one other one I can check. And it's also true for that row there. So this is what we're talking about when we say, can you find a pattern? I'm noticing every single time when I add that first number and that second number, it gets me to 1600. So if I wanted to describe that with a relationship, describe that relationship with an equation, we can generalize that pattern I'm noticing using x and y. I'm noticing every single time I add my x value plus my y value, it's giving me 1600. So for an equation that represents this table, I could say x plus y equals 1600. That is a really big observation that helps us get an equation. Now, I want to talk about why that is for a moment. Remember, our situation here is talking about a plane flying between New Orleans and San Diego. I want to think about what that looks like real quick. So here's New Orleans. That's where it took off. And then it's landing in San Diego. When we're looking at where that plane is on that flight, let's say this point right here. If we're saying that distance from New Orleans, which we're calling x, and that distance from San Diego, which we're calling y, if we say x plus y equals 1600, it must mean that that total flight is 1600 miles. So if you've already flown 100 miles, you've got 1500 miles left to fly. If you're 500 miles from New Orleans, you've already flown 500 miles, it means you have 1100 miles left to fly. It's telling me that the total distance of the flight is 1600 miles. That part right there is the interpretation of this equation. I figured out the equation, but I also want to know why the equation looks that way, and it has to do with this idea here. Now, regarding this question, now that I know what this relationship is, it can really help me figure out those missing numbers there. If I know that this number here plus this number over here, so 1020 should equal 1600, that information is going to be what helps me figure out this missing number. Now, if you're thinking about that, what am I going to need to do to actually calculate this missing number here? Well, if I know this missing number plus this number is 1600, I'm going to have to do that 1600 minus 1020 to figure out that missing number there. I'm going to leave that math there because that's going to be important in a moment. If you do that subtraction, 1600 minus 1020, that's going to leave us with 580. Go ahead and see if you can find this missing number down here too. For this one, it's going to be similar to this one in the sense that I'm going to need subtraction to help me figure it out. If I know these two numbers add together and give me a total of 1600, I'm going to have to do 1600 minus that 1450 to figure out that missing number. And in this case, it's going to be 150. So this is where the other part of this lesson comes in, is I had one equation already that represents this table, but I'm noticing a different mathematical operation here. I'm noticing subtraction can be used to represent this table as well. When we're talking about representing situations with equations, a lot of time there's more than one equation you can use to represent the situation. So if I'm looking up here, what math did I have to do to find that missing number? Well, I had to take that 1600, because we know 1600 is a really big number for this situation. And I had to subtract 1020. That was the y value. So I'm going to say 1600 minus the y value to calculate 580. And 580 was that missing x value. So this right here, 1,600 minus y equals x. That could be another equation representing this table here. Go ahead and looking at this row here, there's a third equation we could write as well. See if you can figure out what that third equation is. And if you get stuck, think about what math you had to do here to figure out that missing y value. For this one here, we're taking that 1600 again, and we are subtracting, this time we're subtracting the x value. And when we do that, it gives us the y value. So we get this equation here is also an equation you could use to represent this situation. So we ended up with 1, 2, 3 equations that we could use to represent this table. They're all related to this idea of the total distance the flight is being 1,600 miles. Those subtraction equations are just saying there's a total of 1,600 miles. So if we subtract out what you've already flown, that's going to give you how much you have left to fly. Or if you subtract out what's left of the flight, that's going to tell you how much of the flight you've already done. Notice all of these equations we were able to figure out after we noticed what this pattern is. So if you're given a table and you're trying to figure out what that equation is that represents the table, or even if you're trying to figure out missing values in that table, we've got to start with what that pattern is, what that mathematical relationship is between the numbers, keeping in mind you're trying to find the relationship between x and y. So trying to figure out how those two numbers there are related. There's one other example we can talk through together in this summary video, and that's going to be this one here, which is about donations to charity. We are told a company decides to donate $50,000 to charity. It will select up to 20 charitable organizations as nominated by its employees. Each selected organization will receive an equal amount of donation. Our goal is to figure out what that relationship is between the number of selected organizations, N, and the dollar amount each of them will receive, D. I want to pause here just to make sure we're all on the same page of what information is to be given to us. So we're told, what is the company doing? Well, the company is, let me get my highlighter, they're donating a total of $50,000 to charity. Now, is that $50,000 going all to one charity? No. It says they're going to select up to 20 charities. Up to 20. What does that mean? Up to 20, well, that's a maximum of 20. So they could select 1 charity, 2 charities, 5 charities, 10 charities, 20 charities. They haven't decided yet how many charities they're going to donate to. And then there's one last key part here. That last key part is however many charities they decide to choose, they're all receiving an equal amount of donation. So if they pick 2 charities, they're not giving almost all their money to one charity and then chump change to the other one, right? It's going to be equal. Our goal, again, is to figure out what that relationship is. So our goal is to come up with an equation here. Now, you might already have an equation in mind, but at some point in your life, you're going to be given a situation like this where that equation isn't going to be obvious to you. And I want to use this question here as an example of why we love tables in math. Tables are huge because we've been talking about how tables are a great way to help you notice the pattern. And by noticing the pattern, that helps you come up with the equation. So notice this question didn't ask me to create a table, but if you're stuck or if you're just unsure and you want to check and see that you've got that mathematical relationship correct, creating a table is going to be super, super helpful. So before I try creating any sort of equation for this, I'm going to go ahead and create a table for myself. My first column is going to be talking about the number of organizations they're donating to. So I could just write N here, but I'm going to also define it just so I don't forget. M is going to be the number of organizations. And then my second column is D, which is the dollar amount per organization. So this is how many charities they pick. And then the second column is how much money each charity gets. So for example, and this is part of the creating the table, is just picking some random numbers here. So for example, I'm going to pick they donate to one charity. How much money does that one charity get? Well, if they only have one charity, that one charity is getting all of the money. So that's $50,000. But what if they pick two charities? Well, two charities are going to have to split that money. So they're going to have to split that $50,000 between the two charities. And that's going to give me $25,000 for each charity. We could go ahead and pick a few more random numbers. I'm going to pick maybe 5 charities next. How much money would each charity get if we picked 5 charities? And pay attention to the math you're doing to figure out that number there. Well, if they pick 5 charities, we're splitting that $50,000 between 5 charities now. So that would leave $10,000 for each charity. And I'm going to pick one number. It doesn't matter which numbers you put there. I'm going to go with, they picked 10 charities. One last one for us to do. How much money would each charity get then? Well, now we're dividing that $50,000, that total money they have, up by the 10 charities. So that would leave $5,000 per charity. The goal of creating a table, it's not because the question asked for a table, because it didn't, but the goal of creating this table is for me to start to notice a pattern. What math am I doing every time? And once I see that pattern, then I can just generalize it with my equation. So this is where I'm going to let you take over. Go ahead, pause the video now, see if you can use any patterns you notice in this table to help you come up with an equation. Hopefully the first pattern that's sticking out to you is that math we had to do every single time to figure out what D was. Notice every single time I was using division, it means I can write an equation with division in it. Each time I was taking that total money they had and dividing it by something. That number I was dividing it by, it changed. It changed depending on how many organizations, how many charities they were donating to. Every single time I was taking that $50,000 and dividing it by the number of charities. So I'm going to say $50,000 divided by N. And when I do that, it equals something. Every single time when I did that division, I was using that division to help me figure out that dollar amount each charity got. So we could say it equals D. That is one equation that represents this situation here. There are more equations. If you've already got another equation, that's super awesome. But if you don't, I'm going to leave you with this table for a moment. Try pausing the video again and seeing if you can come up with another equation that we could use to represent this table here. The other equation we could write is going to use a different operation. Instead of division, the other equation we could write is going to have to do with the opposite of division, multiplication. See if you can, if you don't already have an equation with multiplication, see if you can come up with what that multiplication equation might look like. As I'm comparing the 1 and the 50,000, the 2 and the 25,000, the 5 and the 10,000, I notice that every single time when I multiply that X value times my Y value, every single time I'm getting 50,000. 5 times 10,000 equals 50,000. That's going to be because if we multiply how much money each organization gets times the number of organizations, it's going to take me back to that total money they have for the organizations. By noticing that, I can go ahead and generalize that with an equation. Every single time I can multiply the number of organizations, that's N, times the dollars amount for each organization, that's D, and that's going to give me every single time $50,000. So we get that equation there as another option for an equation that represents this table here. I hope you found this video helpful. Again, writing equations to represent relationships, it is not something we are done with after we move on to tomorrow's lesson. It's something we're going to continue to work on throughout this unit, throughout this quarter, throughout algebra and your future math classes. But the themes of today, remember, are patterns are super, super important when it comes to writing equations, and creating tables and looking at tables are huge tools. They're great tools to have in our toolbox to help us discover those patterns and in turn figure out what that equation is. I hope you found this video helpful. Thanks for watching, and I'll see y'all later. Bye.